The cross product is denoted as X, as you see, amp cross product or Cartesian product depth. The cross product simply returns a relation أو بتعمل جدول جديد بيتكون من كل الاتريبيوتس بتوع الجدولين جنب بعض. So the resulting table will have all attributes that employee, e-number, e-name, gender, salary, D and O, along with the attributes of table depth, which is d-number, d-name, and location. This is for the attributes. What for the records? It takes the first record in table employee and places it in front of the first record in table department, resulting into this: 1 Ali, male, 2500, the DNO 33, D number 11, finance, the department name, and location is Cairo. Then it takes the same row with the next row in table depth. So it places it in front of 22 IT Cairo, and then it takes it in front of 33 sales Giza. Then it goes to the second record in table employee, which is 2 Nadia female 3522, and place it once in front of each of the records in table depth and so forth. The cross product of the two tables will result in a new relation or new table with 6 times 3 records, which is 18 records, the combination of all records from both tables. Okay, if we apply further operations on this table, now this is the table we have that is a result from employee Cartesian product department. What if we made a selection on this table, and the selection condition is that the D and O is equal to the D number? In other words, it will look for the records where the D and O here is equals to the D number here and just consider them. So we're talking about from Ali, one record from Ali, one from Nadia, one from Omar, Ahmed, Yusuf, and Salma as well. So the rule says, from here we can arrive to another rule or another operation in relational algebra, which is any cross product followed by a selection operation is equivalent to the join operator. What's the join? This is the symbol of the join, and as denoted, we write down the selection condition next to it. So we are joining employee table with depth table on the condition that the D and O equals the D number from table department. This join specifically is called equijoin. Why equijoin? Because the comparison operator we are using in this join is equal. This means that we can use any type of operators: greater than, less than, greater than or equal, less than or equal, not equal, when joining two attributes or two tables together based on a specific condition. But the most popular type of joining is the equijoin, where we match only the compatible records from each table in front of each other. Now, if you look for the first result, for instance, I'm having the information of Ali, employee, in front of his department information, where really Ali works for the sales department, and so forth for Nadia. The IT department where she belongs to is mapped in front of her. So now the information is somehow logical. Moving to another type of join, which is the natural join, and it is denoted by the star or the asterisk. Actually, the only difference between the equijoin and natural join, if you realized from the previous slide that the equijoin duplicates a column. In other words, we had an attribute for the D and O, which holds the same values as the attribute of the D number from table department. Natural join omits this attribute in just case that the two attributes or the joining attributes having the same name. So if in the previous example the emp table holds D&O department and the dep table holds D&O department as well, we can apply the natural join directly and it will reproduce a single column attribute with the name D&O instead. This is not a problem actually, as we can rename the attribute in table department with D&O and apply natural join directly. Let's consider an example on the natural join. Here we are doing a natural join between a department table. If you can see, the department table has a D name, D number, the manager SSN of the department, and the manager start date. And because the schema states that the department has several locations, so we have another relation or another table for department locations holding each department number and its location. We want to apply the natural join between the two tables. What does the natural join will do? It will first detect the common attribute having the same name in both relations. Yes, indeed, D number in table depth location is a foreign key from the D number in table department and they are having the same name. So it will simply place the first record here in front of all department locations having the same D number, which is number 5, same for department number 4 and department number 1. The result would be a table with only one attribute called D number and the other one that was supposed to be there in the place of the arrow would not be formed.